In this video, I'm going to use the first derivative test to find the extreme values for function f of x is equal to x plus 2 cosine of x, where x comes from the interval 0 to 2 pi. First, we need to find the first derivative and set it equal to 0. So what is the first derivative of f of x? Which is going to be derivative of x, which is just 1, plus the derivative of 2 cosine of x, which is going to be negative 2 sine of x, because derivative of cosine of x is negative sine of x. So it's going to be negative 2 sine of x, and we need to set it equal to 0 and solve for x to find the critical values. So let's go ahead and solve for x. What do we get? Sine of x is equal to 1/2 if we solve for x here. Now, for what values of x in this interval, we are going to get sine of x to be 1/2, which is pretty easy, by the way. When x is equal to pi over 6, that's one option. So sine 30 degrees is 1/2, or sine pi over 6 is 1/2. And the other option is, by the way, 5 pi over 6. So these are the two options that we need to consider. So that kind of divides our number line into 3 regions. So in our case, so let's say this is my 0, this is my pi over 6, and this is my, let's say, 5 pi over 6, and let's say this is my 2 pi. So we need to consider these 3 regions, this region, and this region. Now, if you play around with some numbers in each of these intervals, let's say between 0 and pi over 6, and plug it into this, you'll see that the sign you get here for the derivative is positive. And it is 0 right here. And if you pick a number in this interval from pi over 6 to 5 pi over 6, okay, you'll notice that the sign of derivative, or f prime of x, is going to be negative. That means all the numbers in this window or in this interval is going to be negative. And then you can pick another number here and you will see it's positive. So it goes positive, negative, and positive. So now let's see what happens at pi over 6. X equal to pi over 6. X is equal to pi over 6. Okay? It goes from positive to negative, the slope, which means, by the way, it is nothing but a local maximum. If the derivative to the left of the critical point, my critical point is pi over 6, is positive, and to the right it's negative, then it's local maximum. And we can easily find that value. Let's go ahead and find it, by the way. So we need to evaluate the function at x is equal to pi over 6. So that's going to give me x plus 2 cosine of x of pi over 6 plus 2 times cosine of pi over 6. Okay, that is going to be pi over 6 plus 2 times cosine of pi over 6 is square root of 3 over 2. That is going to give me pi over 6 plus square root of 3. So that is going to be the value of this function at pi over 6, and it's a local maximum. Now at x is equal to 5 pi over 6, look, on the left of this critical point is negative, the derivative, sign of derivative, and to the right is positive. So according to the first derivative test, it should be a local minimum. Okay, so f of x is equal to 5 pi over 6 is going to give me 5 pi over 6 plus 2 times cosine of 5 pi over 6. This is going to put cosine in the second quadrant, right? So which is going to be negative. So it's going to be 5 pi over 6 plus 2 times negative square root of 3 over 2, that is going to give me 5 pi over 6. This 2 and 2 is going to cancel, minus square root of 3. And this, by the way, is a local minimum. So what we have done is this. We have looked for extreme values for this function in this interval, and we found that there are two critical points in the interval. One is 6 pi over 6, another is 5 pi over 6, that divides the interval into three regions, 0 to pi over 6, then pi over 6 to 5 pi over 6, and from 5 pi over 6 to 2 pi. And we pick a point in each of these regions or each of these intervals, okay? And then plug in that value into the derivative and look for sign. In the first one, leftmost one, we found positive, middle one we found negative, and the right one we found positive. Then we apply the first derivative test to find the local maximum or minimum based on the signs of the derivatives on either side of the critical points. I hope that this discussion was helpful. Thank you very much.